To start general, energy is captured by electrons, specifically free electrons, which reside in an atom's outer shell as valence electrons. They are easily plucked off by an outside force and carried around as energy. An overall negative charge means too many electrons, because electrons are negatively charged particles. An overall positive charge means not enough electrons. Charge is denoted as a lowercase q, and the units of charge are coulombs, denoted as a capital C. Coulomb's law is F equals K Q1 Q2 over R squared.
Coulomb's constant, K, equals 9 times 10 to the ninth Newton meters squared over Coulomb squared.
But Coulomb's law is only good at finding the force of two tiny charged objects, such as particles. To find the force of several charged objects, or larger, different shaped and sized objects, we must use physical components in Faraday's findings. Faraday found that every charged object generates an electric field that permeates space and exerts a force on all charged particles it encounters.
Here I have a plastic cup and a stream of water from the faucet. This stream of water is made up of water molecules, which are polar. This means that they have a slightly negative side, the oxygen, and a slightly positive side, the hydrogen. This is indicated by the way the electrons tend towards the oxygen side because of their higher electronegativity. We know that electrons are negatively charged, which means that the oxygen side will become negatively charged. Ella now has the plastic cup, which she's going to rub on her jacket, creating static electricity. This makes the cup negatively charged and gives it a negative electric field.
Once Ella rubs the cup on her jacket, creating a negatively charged electric field on the cup, she holds it to the water stream. This bends the stream, pulling it closer to the cup. The positively charged side of the water molecules, the hydrogen side, is what is attracted to the cup. The electric field on the cup is acting on the positive charge of the water molecule. An electric field is a measurable effect generated by the charged object.
This equation states that the electric field of the charged object equals the force of the test charge over the magnitude of the test charge, or Coulomb's constant times the point charge over R squared.
To see this visually, we will start with our positive point charge, big Q, and small test charge, little q. Both big Q and small q generate electric fields. Big Q has a much larger magnitude than little q. Electric field lines are vectors which show the direction and magnitude of the force of the point charge exerted on any nearby positive test charge. The closer small q is to big Q, the greater the force.
Three, two, one, clear!
How did that work?
This works because of two main principles: electric potential energy and capacitance. Marie's life was saved by these paddles, part of a defibrillator, which is a very large capacitor. It discharges stored energy into the patient's body. This current stopped Marie's irregular heart contractions and gave her a chance to have a regular heartbeat again. One of the paddles of the defibrillator is positively charged, and the other is negatively charged, creating a one-way current.
This is a capacitor. One of the large plates is positively charged, and the other is negatively charged. Because of this, particles were moved from the positive side to the negative side. That creates a one-way uniform current. So, particles have a lot of potential energy when they are close to the positive plate, and a little potential energy as they move towards the negative plate. The electric potential difference from one location of the particle to another is called voltage. Voltage is measured in volts, or Newton meters over coulombs.
Equipotential lines are lines that run parallel to the plates of the capacitor. Since we know electric potential decreases as particles move towards the negative plate, equipotential lines have lower and lower voltages as they move closer to the negative plate. So an equipotential line here could have a velocity of 20 volts, one here could have 10 volts, and one here could have 5 volts. Equipotential lines are always perpendicular to the electric field.
A dielectric is an insulating material such as plastic or glass that when placed in an electric field increases the capacitance of the system. Capacitance is the ability of a system to store an electric charge. A dielectric is used to increase capacitance while preventing any charge from jumping from plate to plate. It prevents electrons from crossing the gap between plates.
Dielectrics are often very thin and polar, meaning one side is slightly positive and the other is slightly negative. It is thin because the smaller the distance between the plates, the higher the capacitance. So, by inserting the dielectric into the capacitor, capacitance has increased, along with the charge and energy held, for the same amount of voltage.
Recap, energy is captured by free electrons.
Every charged object generates an electric field that permeates space and acts on every charged object that it encounters.
The closer the test charge is to the point charge, the greater the force.
A capacitor is made up of a positively charged plate and a negatively charged plate, and particles move from the positive side to the negative one.
Potential lines are lines that run parallel to the plates of a capacitor. They measure the electric potential energy.
Electric potential difference is called voltage.
Putting a dielectric into a capacitor, the capacitance is increased.
I'm Marie.
I'm Shayna.
And I'm Ella.
And
Thanks
thanks
for
for watching.